Hello and welcome to today's lesson where we're going to look at how you can work out the density of a regular object which falls into the topic of the particle model of matter for GCSE Separate Science Physics. So in today's lesson our aim is to be able to calculate the density of regular objects. So if we're successful and we learn in today's lesson, we should be able to understand how to measure the density of regular objects, draw bar charts of densities of different materials, and understand how to analyse the data taken from measurements for regular objects, which falls into the following part of the AQA GCSE Separate Science specification. Is using an appropriate apparatus to make and record the measurements needed to determine the density of regular solid objects. Now, in today's lesson, if we're successful, we should be able to find the densities of different regular objects and conclude which of the materials is the most dense. So in the following investigation, you would need the following materials: a top pan balance, a ruler, and different materials of different elements or metals. Now, to work out the density of symmetrical or regular objects, you take a material and place this material on the balance. You ensure the balance was zero beforehand and you measure the mass of the material. So then, using a ruler, you'd measure three different lengths of the material and use this to calculate the volume of the material. Now, it would normally be length 1 times by length 2 times by length 3. You can then calculate the density of the materials by using the equation density is equal to mass over volume and repeat this for the different materials. So first step, you would get a balance and ensure the balance is zeroed. Now, if the balance reads a non-zero value when there's nothing on it, it has a zero error, which is the type of systematic error. Now, to remove a zero error, you either subtract the value from the reading or you reset the balance. You would then get a 30 centimeter ruler. Now, the 30 centimeter ruler can measure to 1 millimeter, as that's the smallest division possible on the ruler. So that therefore means the resolution of this ruler is 1 millimeter. So the resolution is the smallest possible value that can be read on the device. Now, a high resolution gives you accurate results. Now, what you would do is you would get a regular or symmetrical object and you would then measure the particular volume that it had. Now, over the course of this required practical, you expected to measure the mass and the volume of many different materials. So all these different letters you'll be expected to measure the mass and the volume of to work out their density. So you will place a block on the balance and record its mass, ensuring, like we said before, the balance reads 0 before the material is placed on it, otherwise you would have a zero error. You would then take the material off the balance and measure length 1 with a ruler. Now think about the resolution of the ruler compared to the measurement taken. Is there a better way to measure length than with using a ruler? You would then do length 2, then you would do length 3 and use this idea to calculate the volume of the material and therefore the density. Now, to increase the resolution of your length measurement, you should use a more sensitive device than a 30 centimeter ruler. Now, sensitivity refers to the smallest division of the measuring device. If you increase your sensitivity, you're increasing your resolution. So for example, a more sensitive device would be something called a screw gauge micrometer, which can measure to the length of up to 0.01 millimeters. So this is a smaller division than what a 30 centimeter ruler can produce. So therefore it has a greater resolution. Another more sensitive device which you could measure length with is something called a Vernier Caliper. Now, a Vernier Caliper can also measure length to 0.01 millimeters. So the Vernier Caliper has a resolution of 0.01 millimeters, and this is a smaller division than the 30 centimeter ruler, so it has a greater resolution and therefore it increases the sensitivity that the measurement is taken towards. So once you've taken off your material and you've measured your lengths with either the ruler or the screw gauge micrometer or the Vernier Caliper, you have to ensure that you align your measuring device so the scale is starting at the edge of the material, as such, as shown in these particular diagrams. Otherwise you would get another systematic error in your experimental results, and then you would use this to calculate the volume of the material by saying volume equals length 1 times by length 2 times by length 3, and therefore you can work out density by saying density is equal to mass over volume. Now, you'd measure all the different reference materials and record the results of the investigation. So you would have to look at brass here, wood here, steel, Aluminium. Now note, aluminium comes in many different shapes and sizes, but in theory the density for all aluminium should always be the same. And you've got iron here, wood here, polystyrene here. And then what you can do is you can fill in your observations in the following table. Note, you would work out your mass by looking at the balance reading. You would then have your length 1, your length 2, your length 3, which is then measured with the appropriate measuring device, ruler, screw gauge, micrometer or vernier caliper. You then work out the volume by timesing those lengths together, and then the density is equal to mass over volume. Now note the units of the density in the table. It's the units of the mass divided by the units of the volume. So in this case it's grams per centimeter cubed. You would then draw a bar chart of your experimental data and place the reference on the x-axis and the density on the y-axis, and then in theory you should get a graph or a bar chart for your experimental results as the following, and from this you can work out which material has the highest density. So in theory, what you'll be able to do in today's lesson, you should be able to use appropriate apparatus to make and record measurements needed to determine the density of a regular solid object. Now the volume should be determined from the dimensions of a regularly shaped object, and dimensions are to be measured with appropriate apparatus such as a ruler, a micrometer or a vernier caliper. So if we've been successful and we've learned in today's lesson, we understand how we can measure the density of a regular object. We can draw a bar chart of density for different materials, and you can analyze the data taken from density measurements for regular objects. I hope you've enjoyed today's lesson looking at the experiment on how you can work out the density of a regular object. Thank you very much and have a lovely day.